So if you do choose to leave and you want to do this independently, it's absolutely okay. I will be posting this video in case you need to reference it after, so it will be here as well. Okay, so when we have our equations, we always have 4 different letters that basically tell us the transformations. So just as a reminder, we have our A here, and A is responsible for 2 things. It's responsible for our reflection in the x-axis, and also for our vertical stretch or compression. So this is the stuff that you should have had in the last lesson. Then we also have our K, and our K is responsible for a reflection in the y-axis, and then a horizontal stretch or compression. And then we have D and C, and I think D and C are a little bit more straightforward. D represents a horizontal shift or translation. You can use either word, it doesn't matter. And remember, if D is negative, we're going right. If D is positive, we're going left. And finally, C is our vertical shift or translation. You can use either word. I tend to use translation, but whatever you're more comfortable with. Okay, so that's the first part that you need to know from lesson 1.6. And I'm just going to quickly erase those because we're going to get into the transformations specifically for each of our parent functions. So in lesson 1.6, you had the equations written out generally, and then you were just applying your transformations to your parent functions. That's not usually how they're written. That's just an intermediate step to get you started. Here, we have how everything is going to be written. So if I look at my first one here, we're going to look at y equals x squared, or f at x equals x squared, and look at the transformations. So if I'm going to write my A, K, D, and C into my x squared equation, it's going to look like this. So the A always goes out in front. Inside the brackets, or touching the X, is where we'll find K and D. And then our C is just tacked on at the end. So we'll do a few examples of identifying these. So if I look at this first example, I have f at x equals 4, all in brackets, negative, x plus 3, all squared. So the first thing that we do is we identify our A, K, D, and C. If there isn't one of those letters, we just leave it and it doesn't impact our equation. So because we have an A value of 4, that means we have a vertical stretch by a factor of 4. And what that means is that we would multiply y's by 4. Now, because our A value is positive, we don't have to worry about any reflections over the x-axis. It's just a stretch. Next, we identify our K. So because I have a negative in those brackets, that will be my K value. So when my K is negative, I have a reflection in the y-axis. And I think that K is the most challenging transformation to do. So when we get to the practice ones below, we're really going to focus on the ones that have the K's, because that's usually the one that causes the most trouble. So if you're kind of confused about the K's still, don't stress. We're going to go through a bunch of them. And finally, I have a D value of +3. So D represents a horizontal translation. You can also say shift if you want to, but I like the word translation. And that would go 3 units. And because it's positive, we're going to the left. So this is the first thing that we want to do, is we want to be able to identify all of our transformations. Okay, let's look at our next one. So our next one is our root function. And our root function has the a out in front, and then underneath the square root is where we'll find our k and d. So that will help you to identify those. And then the c will be outside of the square root, just hanging out by itself. So if we look at this example, we don't have an a value. I do have a number multiplied in front of my x. So I do have a k value. And then I don't have a d value, but I do have a c hanging out on the end. So now, using that information, let's identify our transformations. So we don't have an a value, so we just don't worry about that. Because we have a k value, we look at the sign, it's positive, so we don't need to worry about any reflections. But because we have a value of 1/2, we have a horizontal compression. Oh, sorry, I'm getting my A's and K's mixed up. It is a horizontal stretch. Sorry about that. K is always the hardest one. We have a horizontal stretch by a factor of, and we always say by a factor of 1 over k. So in this case, it's 1 over 1/2, which just equals 2. So we have a horizontal stretch by a factor of 2. That's for our k. And now we need to address our c. So our c moves our function up or down. So in this case, because our c is negative, we have a vertical translation, 7 units down. So that would be our final transformation. Okay, let's look at our inverse function here. So we have f at x is 1 over x, and that would transform to f at x equals a over k, x minus d plus c. And my a is always living in the numerator, and then in the denominator is where I'd find my k and d. And finally, just tacked on at the end would be my c. So let's look at this example and try to identify our a, k, d, and c. So to start, my a is always just living in the numerator by itself. So there it is. Next is k, and k is in front of the brackets in the denominator. So I have this little negative here. That would be my k. Next is d. So d would be in the brackets in the denominator. So there it is, -4. And finally, my c is just tacked on at the end, and it's at -3. So now let's write out what all of these do. So firstly, we have an a value of 2. So because it's positive, we don't have to worry about any reflections over the x-axis. So we can just say that we have a vertical stretch by a factor of 2. Now let's look at our k and see what that does. So we have a -k. So because k is negative, we have a reflection in the y-axis. And if you have to go back to your lesson 6 notes to just remind yourself of what each of these do, that's absolutely fine. You'll start to get it the more you use it. Next is d. So because d is -4, we have a horizontal, translation, 4 units right. So remember, because 4 is negative, we're going to be moving to the right. And finally, we have our C. Dimitri, I'll get to your question in just a moment after I finish C. And C would be a vertical translation, 3 units up. Okay, Dimitri, feel free to turn off your mic, or you can just type your question in the chat, whatever you're more comfortable with. If the number is positive instead of negative, does it reflect on the x-axis instead or something else? So if my A is positive, nothing happens. My graph stays exactly where it is. If my A value is negative, then it flips upside down as if the x-axis were a mirror. So if it was a smiley parabola, then you go down. Exactly. If it's just positive, nothing happens. So same with K. If K is just positive, then nothing happens and I just leave it. Yeah, so we only need to worry about when it's negative, which is kind of handy. Okay, our final one here, I don't have a ton of space, so I might have to write small, is our absolute value function. So my A is on the outside of the absolute value function. Then on the inside of the absolute value bars, we have my K and D, and then outside, just tacked on at the end, is my C. So let's go through our transformations quickly. So because I have an A value of -3, I first need to address the negative. So the negative will have a reflection over the x-axis. Then we also have a 3. So the 3 is a vertical stretch by a factor of 3. Next, let's look at our K. So K here is -4. So because K is negative, we have a reflection in the y-axis. And then, because K has a value of 4, we have a horizontal compression by a factor of 1/k, which is 1/4. And remember, for my stretches and compressions, we don't need to worry about the negative anymore. We've already addressed that with the reflection. We just use the number by itself without the sign. And finally, we have the D value, which in this case is +3. So we have a horizontal translation, 3 units. And because it's positive in the equation, we're moving to the left. Okay, so that's our first part here, is identifying all of my transformations. And now we're going to practice graphing them again. And I think that that is the hardest part of lesson 1.6. So again, if we start graphing these and you've already got it and you feel comfortable, feel free to try them on your own. And I've already posted the solutions so you can look at them. Okay, so here's our first one. And we have f of x equals 1/2 x plus 1 all squared minus 4. So the first thing we always want to do is identify our parent function. So because we have a squared in there, that's telling me that my parent function is f of x equals x squared. So that is my parent function. So let's start by just drawing our parent function on the graph. So if you're at a point where you still need to reference lesson 5 for your parent functions, that's absolutely okay. You do want to get to a point, especially for grade 12, to know, kind of just know these off the top of your head. So that is just f of x equals x squared. So I'm going to label them as we go so we can keep track. Now let's identify our a's, our k's, our c, and our d. So the first thing I always need to do is I need to see if there's any numbers in front of the x here that need to be factored out. If it looks like that, where it's just a number touching the x with another number over here, I always need to factor it out. So let's do that first. F at x equals, factor out the 1/2, leaves us with x plus 2. So, all squared minus 4. So it's important that we write it like that in order to find our d value and the k value. Next, let's identify all of our a's, our k's, c's, and d. So we'll start with our a value. So if I look here, there's no number in front of the brackets, so I don't have an a value. So that's okay. Next, I identify my k value. So that is inside the brackets in front of the k. So what does that do? I have a k value of 1/2, so it's positive. No need to worry about any reflections. But I would have a horizontal stretch by a factor of 2. And the reason it's 2 is because we have to do 1 over k. Yes, Ray, you can either unmute your microphone to speak or you can just type in the chat. So what I did here is I factored out, I'm just going to write it up here to have a little bit more space. So what I did here is I factored out the 1/2. So I originally had f at x equals 1/2 x plus 1 squared minus 4. And I want to factor out that 1/2. So I'm going to divide that by 1/2 and divide that by 1/2. So 1 divided by 1/2, so we keep the 1/2 out here. That will just leave me with x, and 1 divided by 1/2 is going to give me 2. That's where that comes from, because I just factored out that. Okay, awesome. All right. It just, I think that it being a fraction makes it kind of confusing. All right, so that's what our k does. And when we have a horizontal stretch by a factor of 2, what we do there is we're going to multiply x values by 2. So let's start there and do that. So I'm going to look at my graph. I'm going to multiply all of my x values by 2. I start with this here. The next one was 1, 1. I'm going to multiply the x value by 2. And then we had 2, 4. I'm going to multiply the x value by 2. So that would move it to 4, 4. And now I'm going to do the same on the other side. So all I'm doing again is multiplying my x values by 2. There we go. And then I just connect those in a nice line. And now I'm just going to label it. So I have f at x equals, we've just done the 1/2. So that's all I write. All right, oops. I just accidentally should have written it like this. Okay, now let's look at our next one, which is d. So we have a d of 2. So that means that we have a horizontal translation, 2 units, in this case, to the left because it's positive in the equation. And then we can start moving it on the graph. Yes, Afshel. You can speak or you can type in the chat, whatever you prefer. So the reason I have a horizontal stretch by a factor of 2 is because I always have a horizontal stretch by 1 over k. So in this case, it'd be 1 over whatever k is. So again, we have that 1 over 1/2 situation. So that just gives me 2. So that's where it comes from. So my stretches and compressions for my k's are always 1 over k. Yes, Keith. Oh, okay, no worries. If you have something else, just type in the chat again. Okay, so we have our d value of 2. So we're moving 2 to the left. So we're going to take all the pink dots and move them 2 to the left. Oops, I have to change my color to orange. If you are doing this by hand and you happen to have other colors, I would recommend doing it with some color. It does make a difference if you're a visual learner to be able to see them all a little separately and see where they moved. There we go. I connect them with a curved line. So again, what I've done is just taken all the pink points and moved them 2 to the left. Okay, and finally, I have to deal with that 4, my little c value here. And because we have a -4, I'm just going to write this out, and then Ethan, I'll answer your question. We have a vertical translation 4 units down. Ethan, you can turn your mic off, or you can just type in the chat. While you're typing, I'm just going to take all of these orange dots and I'm going to move each of them down 4. There we go. Like that. All right, so your questions there, I'll just connect these and then I will get to your question. So that blue one is our final parabola. At what point are, sorry, I see to move my multiply when you have a horizontal or vertical stretch or compression. So that's a really good question. And we're going to go through a bunch of examples with different options to show you as many as possible. So with my a value, I'm always going to multiply my y's by a. So if I have an a value, I'm always just going to multiply my y's by whatever a is. If I have a k value, then I always just multiply my x's by 1 over k. That's very consistent. So if I have an a value, multiply all my y's. If I have a k value, multiply all my x's by 1 over k. Does that kind of make sense? Okay, we're going to do a bunch more like that. So hopefully when you see it in practice, it will help clear things up. Okay, so this blue one over here is our final parabola with all of our transformations done to it. And now we just want to look at the domain and range. So if I look at my domain, there's nothing stopping my x's. My little arrows on the sides can go on forever and ever. So that means that we have x is an element of real numbers. And now for my range, if I look here, I notice that there are no y values below here, right? There's no y values down there. All the y values are up here. So what that means is that My y is an element of real numbers because I connected these with a nice curve, but y has to be bigger than or equal to -4. So we have f at x equals 1/2 square root of -x plus 3. So the first thing we want to do is we want to identify our parent function. So because I have a square root there, my parent function is f at x is root x. This is our square root function. And now I'm just going to start by graphing my parent function. So again, if you need to reference your Unit 5 notes at this point, that's absolutely okay. And I need to zoom that a little bit more, 9 and, oh gosh, sorry. Sometimes that happens when I'm on my iPad. There we go. So it will look like that. Now let's identify our A, K, C, or D. So we'll start with an A. So we have an A out front here. Because there's nothing else inside the brackets or underneath the square root, there's no need to factor the K out of anything. We can just use the K straight away. So there's my K. And finally, we have a little C at the end here. So let's look at all of those transformations. So the first one, we have an A value of 1/2. So it's positive. So we don't need to worry about any reflections. But because it is between 0 and 1, we say we have a vertical compression by a factor of 1/2. And when it's my A value, I always just multiply y's by 1/2. So no matter what the A value is, I always just multiply my y's by my A. So let's go through and do that. There we go. And I'll just label that. I should have labeled the first one, but that's okay. Y equals, oops, f at x equals 1/2 root x. Okay, yes, Dustin? As you type, I'm just going to write out what k does. So because k is negative, we have a reflection in the y-axis, like this. So that means it's going to be mirrored over the y-axis. So Dustin, as soon as you're ready, feel free to type your question into the chat and I'll address it. So I'm just going to flip this green line over the y-axis. Like that. So that is my reflection over the y-axis. Can we rate a compression as a stretch? No, we should always write stretch of 3, compression of 1/2. That's the proper terminology that we want to use. Okay, so now we have f at x. We've dealt with the 1/2. We've dealt with the -x. And finally, let's deal with the c. So because we have a +3 at the end there, we have a vertical translation, 3 units up. So now let's move all the pink dots 3 units up. And then we connect them. Sorry, my lines aren't so nice. It's kind of hard to do on the iPad. So now we have f at x equals, and we've done the 1/2. We've dealt with the negative x, and finally we've dealt with the positive 3. Okay, finally we need to deal with our domain and range. So if I look at my domain, all of my x's are at 0 and continue over. So x is an element of real numbers such that all my x's are less than or equal to 0. And then for my range, if I look at where my y's are, my y is an element of real numbers such that all of my y's are greater than or equal to 3. And that is our final answer. Okay, let's do another one. So for actually, I will do this one because it has a k in it. So the first thing we want to do is we want to identify our parent function. So because I have a square root living here, my parent function is our square root function. So let's draw that right away onto our graph. There we go. A little wiggly, but that's okay. So that is f at x equals root x. And now we're going to start identifying our a, k, d, and c. And in order to do that, if there's other stuff under the square root, we need to factor out the number in front of the x to identify our k. So we'll factor out that 2, and we're left with x plus 3. And then we have this negative 4 on the end. So now let's deal with these transformations. No a value, so we don't need to do anything with a. That's great. We have a k value of 2. So that means it's positive, so no reflections. But we do have a horizontal compression by a factor of, and remember, it's always 1 over k. So in this case, it is a half. So we're going to multiply our x's by a half. So let's look here. Multiply all of our x's by a half. There we go. Let's run over this. Yes, Dimitri, you can type or unmute your mic and speak. So in this, with my k, I always multiply by 1 over k. We'll just leave this here. I'd make a note of that. So here we took all of our x's and we multiplied them by 1 over 2. So my x in the purple dot was already 1. So when I multiply 1 by a half, it moves over to a half. Same with the 4, when I multiply that by a half, it goes to 2. And same with the 9, when I multiply it by a half, it goes to 4.5. Does that clear that up? Okay, great. All right, so now let's address our horizontal translation with the d. So our d is 3. So that would be a horizontal translation, 3 units. And because it's positive, we're moving to the left. So we're going to take all of our pink dots and move it 3 to the left. And I'm just going to label it. There we go. And finally, let's address our C over there, which is -4. So that means that we're moving down 4. Vertical translation, 4 units down. So let's move all of those orange dots 4 units down. Oops. And there we go. So again, if you feel like you're getting the hang of this, feel free to go and try some on your own. So the next one we're going to do is probably the hardest one. And this is the one people find the most difficult to picture and write the domain range for. Oops, I almost forgot to write this domain and range. A little ahead of myself. So for the blue line, my domain, X is an element of real numbers because we connected it with a nice line. And our X has to be bigger than or equal to -3. Because all of my X's go from -3 and towards the right. And for my Y's, our Y's are an element of real numbers such that our Y's are all bigger than or equal to -4 because they all go above -4. Okay, let's try the tricky one now. So this equation is f at x equals -3 all over x minus 1 plus 2. So the first thing we want to do is we want to identify our parent function. So in this case, our parent function is f at x is equal to 1 over x. This is our last parent function. And this one is the trickiest to graph and to transform. So bear with me because I want to make sure everyone knows where everything came from. So let's start by graphing our parent function. There we go. And remember, we have these asymptotes on the sides here. So our lines can't touch the x and y axis. They get very close, but they don't touch it. So that's our f at x. It's 1 over x. So when we transform this, we do want to keep an eye on where our asymptotes go. So if I move this thing over, my asymptote moves along with it. If I move it up or down, my asymptote moves along with it. So I'll show you what I mean by that. So let's just take note that our asymptotes right now are right here. That's where they're living right now, and they haven't moved just yet. Now let's quickly identify our transformation. So first we have an a value of -3. So because it's negative, we have a reflection in the x-axis. And because it's a 3, we have a vertical stretch by a factor of 3. Like this. So now let's apply those. So let's start with the reflection in the x-axis. So basically what's going to happen is it's like this, and they're going to just swap because we're reflecting over that horizontal axis. It's going to look something like this. So that first one goes here, and it hasn't changed our asymptotes because we haven't moved our positioning, we've just flipped it. There we go. So there's our first one. That x equals negative 1 over x. So we've just done the negative part, the reflection. Now let's do the stretch with the 3. So it's going to get a darker green so you can keep track of what I'm doing. So what I do for a vertical stretch by a factor of 3 is I multiply y's by 3. That's what I'm going to do. So each of my y's I'm going to multiply by 3. Go. So again, this hasn't changed my asymptotes. My asymptotes are still those red lines there. There we go. So that dark green is going to be negative 3 over x. Okay, this is where our asymptotes are going to move because we're going to start shifting this thing left and right. So I'm just going to quickly erase our old asymptote so that we can make room for the new ones. Oops. There we go. So our next transformation is the d value, which is right here. So because it's negative 1, we're going to be moving to the right. So horizontal translation, 3 units right. So now what we're going to do is everything moves over 3 units to the right, including our asymptotes. So we'll take the dark green dots and move them each 3 units to the right. So now instead of getting really close to y equals 0, it's now x equals negative 3. Same thing down here, move everything 3 to the right. There we go. And we see our line getting really close to our new asymptote at y equals 3. Yes, Keith. Why is it not 1 unit? Oh, because I looked at the wrong thing. Sorry. Because I was looking at the 3 on the top. That's why. Thank you. Sorry, it's because I was looking at the 3 on the top and not there. My bad. So because we have x minus 1, it only moves 1 unit to the right. And I moved to the left because I was looking at that negative 3 on the top. Sorry, ignore the whole orange one. We're going to do it again. So we're going to take the green dots and we move them all right 1. There we go. So now positive 1 is our new asymptote. There we go. And same with my dark green lines on the bottom. So 1 is my new asymptote over there. So we can see that the orange lines are getting really close to 1. And now let's do our final transformation. We have to deal with our little c. So this last one here, and we're going to go up 2. So we have a vertical translation up 2 units. So now we take all of the orange dots and move them up 2 units. There we go. And now our lines are almost touching 2. So those transformations move our asymptote. So these ones get a little crazy to look at, but it's the exact same steps. So now let's do our domain and range. So for our domain, x is an element of real numbers, but in this case, none of our x's are able to equal 1 because that's where our new asymptote is. And it's because we moved 1 unit to the right. Next for our y's, y is an element of real numbers such that y cannot equal 2 because we moved 2 units up, which moves our asymptote 2 units up. Okay, so there are 2 more here for you to try. Do you guys want me to go through them or do you want to try them on your own? Can a few people kind of write what they're feeling in the chat so I can get a sense of what you want? I don't mind going through them with you again, doing 2 more, or you can do them on your own. Anybody have a preference? Okay, I'll do them. And at this point, if you're really feeling like you've got enough and you are ready to go, then feel free to leave. Like, no worries about that. You've already been counted for attendance. So if you want to go and work on your own, I will post this video. So no worries, but I will go through the other ones to give people a little more practice. Okay, so let's do another one of these tricky ones. So we have f at x equals 1 all over 2x plus 3 minus 4. So first we need to identify what the parent function is. So because I have a fraction, my parent function is f at x equals 1 over x, like this. So let's start by drawing out our parent function. I find this one the hardest too, because the parent function doesn't have as nice of points as some of the other ones. At the end, we're going to do an absolute value one, which is much more straightforward. So if you're feeling a little confused because of the 1 over x's, don't panic. These ones are by far the hardest. Okay, so that's our parent function there. Now let's start looking at all of our transformations. So because I have a 1 on top of the fraction, there's no a value, so I don't need to worry about that, which is great. Now I'm going to look for my k, and because I have a number outside of the brackets in the denominator, that is my k value. So let's write out our transformations for k. So because it's positive, we don't have to worry about any reflections, which is awesome. But we have 2. So when my k value is bigger than 1, that means that I have a horizontal compression by a factor of, and remember for our k's, it's always a factor of 1 over k. That's different for k's than a's. So it's always a factor of 1 over k. And that means that we multiply our x's by 1/2, like this. So now what we're going to do is we're going to multiply all of our x's of our coordinates by 1/2. Our asymptotes are still going to stay at our axes, the thick black lines, so we can just start moving the purple points. Afshal, you have a question? You can type it in the chat, or you can turn off you can unmute yourself rather. While you're typing, I'm just going to start moving these dots. I'm still looking for your question. Okay, so all I've done, oh, wait, so does that mean no matter what parent function is, if k is the factor, x value is multiplied by 1/2? Not by 1/2, it's always 1 over k. So no matter what the parent function is, if I have a k value, we multiply all of our x's by 1 over k every single time. So hypothetically, if this value here had been like a 5, we would have been multiplying everything by 1 over 5. So it's always 1 over whatever k is. Does that make a little bit more sense? Nicholas? If the k value were 1/2, but that may be a stretch of 2. Exactly, yes. Because I would have done 1 over k. Exactly right. There you go. Okay, so back to our example. So I multiplied each of these x values by 1/2. So this point here, this one here, went from an x value of 2 now to an x value of 1 because I multiplied it by 1/2. Next, this one here went from an x value of 1 to an x value of 1/2. And this one here had an x value of 1/2, and it went to an x value of 1/4. And then I'm still going to connect them. Our axes are still my asymptote, so they're kind of hugging those lines. And I do the same thing below. So all I'm doing is cutting my x values in half like this. And my asymptotes haven't changed. There we go. All right, so that's our first transformation. The next one is going to be our d value here, positive 3. So that one means that I have a horizontal translation, 3 units left. So because it's positive 3, we're moving 3 units to the left. So now I'm just going to take all of my pink dots and move them 3 units to the left. So it's not going to be perfectly exact because we have like quarters and they're not all super nice points. So just do the absolute best you can. The main thing to remember is that because we're moving it 3 units to the left, my asymptote is also going to go 3 units to the left. So now instead of hugging the y-axis, they're going to be hugging x equals 3. So let's move everything over 3 units. So it's going to look like that, still hugging the x-axis, and now hugging 3 as our other asymptote, like this. So let's do it with the other set of dots. we go. So it's going to look like this. There we go. So that one is f of x equals 1 over 2 x plus 3. Forgot to label the other one. F of x equals 1 over 2x. Okay, and our last one is our little c. So let's deal with c here. And because it is a -4, we're going to go down 4. And it also moves our asymptote down 4. So we have a vertical translation, 4 units down. So now let's take those dots and move it 4 units down. There we go. And we can still see it hugging that red line there. And now it's also going to be hugging this -4 because I've moved it 4 down. And we'll move the other set of orange lines. Go. And there is the other one. So again, these ones are by far the most confusing ones. I think after this, once we jump to absolute value, you'll feel like it makes so much more sense, at least the absolute value one. So we have f of x equals 1 over 2 x plus 3 minus 4. Finally, our domain and range. Once you know where the asymptotes are, the domain and range are pretty straightforward. So our domain, we have x is an element of real numbers such that x cannot equal 3 because we have our asymptote going through x equals 3. And for our range, y is an element of real numbers such that y cannot equal -4 because our asymptote is going through y equals -4. Okay, let's do the last one. We have one more. And again, this last one, I think you'll find much simpler, much straightforward, and it will kind of clear up a lot of questions. So here's our last one. And I'll also post this video. It's going to be long, so it'll take me a bit for it to load. But that way, if you need to rewatch it, you can keep rewatching and learning. Okay, so our last one, we have f of x equals 3 absolute x plus 2 minus 1. So first thing we got to do is we have to identify our parent function. So in this case, we're going to have f of x is absolute x. So let's start by drawing our parent function on the graph. So remember, our absolute value is this funny shape here that looks like this. There we go. And now let's start identifying our transformations. So first we look for an a value. So because this is being multiplied and it's not inside the absolute bars, then it is our a value. So it's positive, so we don't need to worry about any reflections, which is helpful. But we do have a vertical stretch by a factor of 2. So remember, because it's my a value, it's just a factor of 2. Oh, sorry, I wrote 2, but in this case it's 3. Because my a value is just 3, so it's just by a factor of whatever my a value is. So that means I multiply my y values by 3. So every y gets multiplied by my a value. So let's go through and do that. So the first point was 1, 1. So I take my y value and I multiply it by 3. And then they just start going over the outside of the graph. So I can only graph 6 of the dots rather, or 5. So just graph what you can. There we go. So I just multiplied my y values by 3. And now I'll identify my next transformation. So the next one, I have a d value there. So I'm going to have a horizontal translation to units. And because it's a positive 2, I'm moving to the left. So now let's take all those green points and move them 2 to the left. There we go. So my green little triangle is moved over to the left. Okay. Now we're going to identify our final transformation, which is our C, which is hanging out on the end like that. So because I have a C value of -1, that means I have a vertical translation 1 unit down. So now I take all of my orange dots and I move them each 1 unit down. There we go. So that is f at x equals 3x plus 2 minus 1, like that. Finally, our domain and range. So our domain, there's nothing stopping it from going on like this forever. So my domain is just x is an element of real numbers. And then my range, so all of my numbers are higher than -1. So all my y's have to be bigger or equal to -1. And that is our final example. So for this lesson, there are some practice problems from the textbook for you to do. I'm just going to pull those up quickly. So it is on page 58, number 1, 2, B, C, D, and then 4 to 8, A, B, C. So you have a few things to work on right now. You can do this homework and you can ask me questions because I'll probably just turn off my camera and just hang out here until people have questions, especially with the review. If you also want to use this time to review for the quiz tomorrow and review lessons 1.1 to 1.4, you can do that as well. And then you can make sure you're working on that portfolio stuff. So that's basically what you have the rest of today for, is just to review, get this work done, work on the review questions, and just ask for help if you need it. So with that being said, I'm going to stop the recording and